Welcome to our video on functional analysis, an intriguing and vital part of modern mathematics. Functional analysis is the study of vector spaces endowed with some kind of limiting structure and the linear operators acting upon these spaces. It provides a framework for formulating and solving various problems in mathematics and physics. First, let's dive into the basics. Functional analysis primarily deals with Banach spaces and Hilbert spaces. A Banach space is a complete normed vector space, which means it is a vector space with a norm such that every Cauchy sequence has a limit within the space. Hilbert spaces, on the other hand, are complete inner product spaces which form the generalization of Euclidean spaces to infinite dimensions. Next, it's essential to understand linear operators, which are mappings between vector spaces that preserve vector addition and scalar multiplication. Operators can be bounded, meaning they map bounded sets to bounded sets, and unbounded. Particularly important are the bounded linear operators on Hilbert spaces, which can be represented using matrices and play a crucial role in quantum mechanics and signal processing. Another key concept is the spectrum of an operator, analogous to the concept of eigenvalues for matrices. The spectrum of an operator encompasses points in the complex plane related to how the operator behaves concerning invertibility. It's categorized into the point spectrum, continuous spectrum, and residual spectrum, each providing valuable insights into the operator's characteristics. In the realm of functional analysis, we also encounter the Hahn-Banach theorem, a pivotal result that allows the extension of bounded linear functionals. This theorem is crucial for the development of dual spaces, where every Banach space has a corresponding dual space consisting of all continuous linear functionals on it. Lastly, we must mention the concept of compact operators, which are operators mapping bounded sets to relatively compact sets. These operators are a generalization of matrices and have properties significantly aiding in solving integral equations and understanding perturbations of self-adjoint operators. Now, with this foundational knowledge, you'll be able to engage in meaningful conversations about functional analysis with experts in the field. Thanks for watching. Like and subscribe for more videos like this.